webinar. Just a bit of introduction. What this short title is really meaning. As we know, the European Union is giving more and more emphasis to its energy policies, whose strategy and actions are delineated in several policy instruments related to different time horizons. Indeed, starting from the Energy Union strategy, the Clean Energy for All Europeans package, including the new EPBD directive and the new directive on energy efficiency and the national energy and climate plans, the 2050 long-term strategy, all have the energy efficiency as one of the main pillars to leverage on to achieve challenging targets as they are mentioned in these policy instruments. But in parallel, new data policy framework set by Open Data Directive and EU data strategy referring to high-value data sets, data spaces, data ecosystems will play a key role in the energy policy context, as we heard also in the previous presentations. This webinar aims at showing the benefits that geospatial information can bring in such a framework, how reusing inspired principles, such as the adoption of common data models and common data access mechanisms. Most of the presentations will refer to ongoing activities in the context of the energy and location applications, activity executed under the ELISE action of the ISA² program of DIGIT. They are run in the frame of a multilateral non-monetary collaboration agreement with several partners like Dutch Cadastre in the Netherlands, University of Applied Science of Stuttgart, University of Applied Science of Saxion in the Netherlands, CIMNE in Spain, Cardiff in Spain, and last but not least, the Agency for Digital Italy and also the Autonomous Province of Trento, as well as the regional energy strategy in Castilla-Leon region in Spain. But we will have also one presentation run by Niall at the end, who will talk about the REDAP project. It's important to mention that all the use cases executed in the context of these energy and location applications are characterized by methodology which basically aims at their reuse in other geographical areas. In the first part of the session, we will have speed presentations highlighting the specific problems addressed and the solutions designed and implemented, whilst in the second part, we'll play a bit with some Slido polls and reply to answers from the audience. This is the full program. We will start from the presentation given by Christian, validating energy simulations result for district models based on GIS data, first experiences on the case of the city of Enschede, and then so on. The long titles are reflecting how specific we are in many energy efficiency related aspects, even though we try, as I said before, to generalize them as much as possible for their reuse across Europe. But before to give the floor to Christian, I kindly ask Francesco Pignatelli, the leader of the ELISE action, to give his welcome speech. Please, Francesco, unmute.
Thank you, Giacomo. In reality, there is very little bit to add to what you said. I just would like to underline the good work done so far by Giacomo and the team of ELISE, and also with all the network that we created, because as Giacomo underlined, this is a non-monetary agreement, so it means that each partner receives the benefit in participating. And I think this is really important, what you will see today, because our practical use case where we are applying inspired principle, inspired data as much we can, also to support other directive other than environment on the energy. And this is the benefit will be that we can reuse some data that will be available anyhow through Inspire, also for other for other directives. So we will align different directives, and this is a saving of time and cost for the member states. Also, I think what is important to see that INSPIRE and this use case will also have the benefit to reach the one of to contribute to one of the new priorities of the new Commission, which is the Green Deal. So all the data from INSPIRE really can be used for this purpose. So I really welcome you all. I see that we have a good number of attendees, and I don't want to steal more time for this interesting session. So I will follow your presentation. And thanks again for your participation.
Thank you very much, Francesco, for your welcome speech. My apologies because I didn't present myself. I did introduce myself. I'm Giacomo Martirano, and I'm working in this context as an external consultant at the JRC, facilitating these energy and location applications project under the ELISE action led by JRC and funded by Digit. So I will start the first challenge to hand over to Christian for his presentation. Christian, the floor is yours.
Thank you very much, Giacomo. I'm just going to take over the screen. That didn't work. Let's try again. So here we go.
We see it.
Perfect. So let's go to the first sheet. My contribution today is titled Validating the Energy Simulation Results for District Models Based on Geospatial Information Data. And we basically present here first experiences on the use case of the city of Enschede. Enschede, for those who do not know that city, is a city to the very east in the Netherlands. If you draw a line from Amsterdam to the German border, you will find that it's 5 kilometers away from the German border. We have here 150,000 inhabitants. We have a local university, the University of Twente, and we have our University of Applied Sciences called Saxion. The sheets I'm presenting are joint efforts from the project teams. That's why I basically mentioned all names on that sheet. We developed collectively an evaluation framework for the simulation results. And let me just share my sheets with you. So how do I move on? Okay, sheet number 2. The aim of that presentation is to fulfill a task, as a task to carry out the evaluation of the validity of simulation results for the simulation of district models based on GIS data. And the contribution documents the first experiences for conducting one of the 3 parts of the evaluation framework for the city of Enschede. And the study compares, in that sense, the results from simulations made with simulation software SimStat for a model made up out of 327 dwellings, which is a local district here in our city. The level of detail we used for modeling is level of detail 1, and we aim to investigate also the impact of level of detail 2 data once we have concluded our preliminary analysis. So when you assess simulation results from any software, you can do that on 3 different levels. First of all, you need to make sure that the level of geometrical detail is suitable for the aspect you are analyzing. You can compare different modeling tools with each other and assess the accuracy relatively with each other. And you can also compare your simulation results with the absolute performance of buildings, of building systems, in a sense that you compare measured with simulated data. And I want to address in my case study a first attempt to compare simulated results from Zimstadt with measured data from the city of Enschede. What I show you on that sheet is a validation framework we developed as a team. First of all, in the top box, you see the assessment of the suitability of the different levels of geometrical detail. You see on the left-hand side the level of detail 1 till level of detail 3. And then you see next to it a gray box, which is describing data giving the type of the dwelling, the construction, as well as climatic details. So the level of detail has to be assessed for your specific analysis task. So that's one part of the evaluation. The second part concerns the intermodal comparison bit, because there is not only Zimstadt to evaluate models on district level. Think, for example, also on think also about tools such as Citizen, but also traditional simulation tools, building performance simulation tools such as PHPP or IDA-ICE could play a role. In our team, we use two tools. We use Zimstadt, and then we have a Spanish tool, which if I'm not mistaken, Gemma, it's called Energia?
Energies, yeah.
Exactly. So that's those two tools we want to compare with each other, and then we can also compare the output of our predictions with actually measured data, and that can be done building specific, or that can be done based on aggregated data, which I'm anticipating to do. So that's a validation framework. I want to share with you the case for which we started an initiative. You see here to the left-hand side the inner city of Enschede. It comprises, when modeled in Zimstadt, of 6,518 building blocks. And because the extent of the model makes it very hard to conduct a detailed analysis, we've actually derived or took one section of that city comprising of 113 building blocks to compare those simulation results with census data. The 113 building blocks correspond to 327 addresses, and that actually is the same as 327 different dwellings. On my next sheet, I show you how we parameterized the model in Zimstadt. It's worth noting that we do not have yet specific building physics libraries and occupancy libraries for the Netherlands. For the indicative first analysis, we used the libraries in Zimstadt that are available for Germany, and that's the EVO 2015 library for the building physics, and it's a standard German library for the building occupancy. I just want to mention here that we are in our group busy with developing databases, libraries for the Netherlands in order to better localize our analysis. Here I show you the first results we obtained with respect to predicting the annual energy demand for heating in kilowatt hours per year. And what you notice is a very small difference from the Zimstadt predictions with the published census data from 2017. So the small difference of 77% encourages us to proceed with the analysis, but we need to take into account that the analysis currently is on on German libraries, and the analysis has to be repeated for the once developed Dutch libraries. But anyhow, the match is surprisingly good. As a next step, we will prepare the comparison of the simulation predictions of Zimstadt with absolute measurements, absolute energy performance energy use measurements are available for all of the Netherlands. It's publicly available data from the energy suppliers, and the data is aggregated on postcode 6. That basically means that you do not obtain energy use data per individual dwellings, but that dwellings are aggregated, or numbers are aggregated in groups of 15 to 20 dwellings in order to protect privacy. So the modeled area, which I did show you, comprises of 18 postcodes at that postcode 6 level. Then I come to my concluding sheet. The very close, the very small difference between predictions and published averaged energy data for the Netherlands seem to indicate that the city GML geometry data are suitable to parameterize the simulation models for the prediction of the energy demand for heating on district scale. Still, there is a strong need to develop localized or specific country-specific building material and occupancy libraries to enrich the simulation models. And the indicative from simulation results show a surprisingly good fit between the prediction and average energy use data, even for the rather low detail present in the LOD1 models. Thank you very much. Do you have questions?
Thank you very much. I think we will move all the questions at the end. You are invited to write them in the chat. And thank you, Christian, for having showed such encouraging results, because we remind that the aim of our use case is to prove that the methodology we are running in these test areas can be easily repeated in other geographical contexts. You know how governments and at different levels to make assessment of their building stock in terms of energy performance okay, I propose to Volker to take control and share your screen and to proceed with your presentation.
Yes, thank you, Giacomo. So do you see the screen?
Not yet. We see you.
Okay.
Which is always good. Okay, it's coming. Yes.
Okay. Good.
Just go to the full screen.
Yeah. Okay.
Thank you.
Yeah. So I would like to go into some details of the mentioned tool SimStat that was introduced, or the evaluation was done or presented by Christian. So what is the main motivation of this tool? We started the development of SimStat some years ago already, with, of course, the overall aim to reduce heating energy demand of buildings, or at least simulate and see what refurbishment strategies would result to. And we always observed that with the classical approach, you start with building footprints, but what you heat is not a footprint, but the volume of the building. So we thought 3D models will have a crucial role here, because they represent the environment or the building in a much better way. And with CityGML, we have a standard how to represent 3D buildings. So it was the idea to use this 3D city models as an input for a simulation, not only on building level, but on city district level and on city level. Yeah, and CityGML is an OGC standard, but in the Inspire framework, there's also a 3D city model in the NX3 defined, and it's very close to CityGML. And we compared these two data formats, and so they model the environment in a very similar way. So that is then the potential that we say, okay, if we see in future more and more 3D city models on European level in Inspire, we can also use these models to do the simulation. And this project or initiative, we want to share this method how we use it to predict heating energy demand on urban scale, and based on the simulation results also derive an energy performance certificate or label. Yeah. And with the main idea to use 3D city models on as an input, and for this we initial tests, and then Christian is doing a more detailed comparison and evaluation as described before. So what is the main principle in Simstadt? We take a 3D city model, and performance has a big impact for us because we talk about many buildings that we want to simulate. So we've chosen a relative simple simulation method, which is a monthly energy balance, but it's based on German DIN norm, but we try to parameterize a lot of things and use building typology libraries to be able to adapt it to different countries as well. So all of the assumptions come from libraries on building physics, for example, or on usage that can be replaced and adapted to national specifications. What is mandatory besides building geometry is the year of construction or information about refurbishment and the function of the building. We know if it's a residential building or commercial building, things like that. And then we simulate the heating energy demand as shown in the sketch below, taking into account solar gains, heat transfer loss, ventilation losses, hot water demand, usage, so internal gains by humans in the building, things like that. Yeah. And then based on the calculated numbers, we derive a label for this building. Yeah. And we tested this in 2 case studies at the beginning of this pilot. The one is in Zwolle together with the Dutch Cadastre. And it's a city with an old center. That's why many buildings are not so energy efficient. Yeah? But that's because these are old buildings in general. Yeah? And we assign this, calculate the heating demand, and then assign this label. And then we already see the difficulties because the categories of the labels are different in Germany and the Netherlands. Yeah, so and that's one of the issues that makes this comparison difficult, because you have with the same heating demand, you get different labels in Germany and the Netherlands. And the second test case is a case study in the area of the city of Essen, where we have an LOD1, LOD2 model. And here we compared both LOD1 model and LOD2 model simulation results and compared it with heating demand. And here you see it's also say geometry has an impact, as Christian mentioned as well. So it's a question, do we need LOD1 or LOD2? For volume, LOD1 and LOD2 more or less lead to the same results, because in LOD1 it's defined in the standard that it's the average height of the roof, so it more or less keeps the volume of the building constant. but of course the roof structure is not known in LOD1, it's only known in LOD2, and this has an impact on solar gains, etc. In general, based on these comparisons, with all the difficulties of comparing simulated data with measurements, we say in general see an deviation between measured data and simulated data about 20%. But as I said, it's also difficult to compare this measured data with the simulated data, because in the case of Zwolle, for example, measured data is not a one-to-one mapping to the building. It's a mapping to a group of apartments that can be in different buildings. So it's not so easy to always assign the measurements to the simulated data. So that's still an open issue. But there are some, based on the results, we have some, say, dissemination or work based on the results that are not part of the pilot, but are, say, follow-up projects based on the work we did in the pilot. I think Jamo mentioned yesterday already in his speech in the workshop on the Green Deal and the role of smart cities, that we conduct this analysis and heating demand calculations for the city of Helsinki. That's work in progress. And here's another example with the city of Rotterdam. So we calculate the entire building stock in Rotterdam with this methodology and design. Both calculated monthly heating demand over a year, so per month for a building, and colorize the building based on this energy label. That's work in progress with the idea to share this in a web-based environment and make it available for citizens as well. And the difficulties, and that takes most of the time, it's not the simulation itself, but it's the adaptation of the building physics libraries to national or local requirements. There we can also use, here in Rotterdam, we try to incorporate knowledge from the energy department of Rotterdam to adapt these libraries to improve the results. Now, that is usually the adaptation to national specific things is the most time-consuming part. It's not the building geometry, that's always the same, but it's more, we have different semantics in building typology and things like that, besides language as well. Yeah? So, but conclusions with the adaptation, it's work to do, but it works in the end as well. Yeah? So it's possible to adapt these simulations to national requirements, but also without doing that, using just the default building physics library, for example, results are not too bad, as Christian mentioned as well. And the difficulty is, I think, the comparison of the heating demand as kilowatt hours per square meter per year, but to compare the different labeling methods, because unfortunately they are quite different in Europe. Questions?
Thank you. Thank you very much, Volker, for having addressed very important points. Many of them, first of all, to having showed how the methodology can be reused in many other cases, touching also the possible key role of Inspire in providing harmonized input dataset to feed SimStat, and also to have highlighted that there are semantic issues to be solved. And I would say that that's why in the previous presentation of Christian, it was highlighted the importance of agreeing on a verification methodology in order to allow any user to make a self-assessment of the uncertainties and the degrees of freedom which are in running the simulation in different contexts. With this, I would like to give the floor to Gabriele for his presentation. We will switch to a slightly different topic, very interesting as well.
Okay. Do you hear me?
Yes, we hear you.
Okay, thank you. Good morning at all. Now I share my...
It's coming. Yes.
Okay, do you see?
Please, Gabriele, go ahead.
Okay. I am Gabriele Ciasullo. I'm responsible of database and open data office of the Agency for Digital Italy. And with the collaboration of Antonio Rotundo and Leonardo Donnaloia, co-authors of this presentation, I work in geographic information sector, in particular for the implementation of the INSPIRE directive with reference to the metadata and the management of a national catalog. We have worked also in definition and the maintenance of technical rules on geographic information. The Agency for Digital Italy is a technical agency of the Presidency of the Council of Ministers and works for the achievement of the objective of the Italian digital agenda and contributing to the diffusion of the use of information and the communication technology. In this context, in particular, we work to promote a wider participation of the public administration in the European program and initiative linked to the digital government, and to define technical rules, guidelines, and methodology for ICT. Also, in the spatial data sector, one of the principal keywords is the interoperability. And we are engaged to improve data interoperability by ensuring that the definition of the new thematic data model will be consistent with the national and European reference specification. The European reference are obviously the INSPIRE data specification, while at the national level, we refer national rules on the geotopographic database. The geotopographic database specification is the result of the activity carried out within the national working group coordinated by a specific committee in Italy. It is a conceptual data model which includes all the basic geotopographic content of the territory and replace traditional cartographic production. Specification represent the content through a structure in layers, teams, and classes. As you can see, the layer number 7 is dedicated to the utility network that have different teams as indicated in the slide. In particular, the teams from 0 to 07 refer to National Information System for Physical Infrastructure, named SINFI, managed by Ministry of Economic Development. Based on the needs of this ministry, we elaborated and updated the data model in line with the national specification, ensuring interoperability among the geographic reference databases. Finally, we developed and updated the data model of the PELL, Public Energy Living Lab, for public lighting, introducing the theme number 8 in the utility network layer of the geographic databases. The PELL project is launched by ENEA, National Agency for New Technology, Energy and Sustainable Economic Development. It promotes in the public lighting sector, both from the energy saving and the operational management point of view. With the action Enea wants to start a change in the management of the strategic infrastructure of the public lighting for the innovation of urban and the territorial context, supporting the digitization of public administration from a smart city perspective. At the present, PELL system is operative since last year, month of June, and provide strategic support to different stakeholders, in particular from infrastructure managers interested in using a professional, transparent, and dynamic platform, policymakers willing to encourage the adoption of innovative services, and the project finance expert involved in the economic assessment of project and in the monitoring of investment risks. From the operational point of view, the platform is currently powered by the production of XML file conforming to the defined data model. Through a specific application, the system allows the transformation of XML file into GML and/or shapefile for a correct use in GIS system. In a final overall view, in a final vision, the PELL platform is proposed as a smart city as a services platform that collect different type of data from different infrastructure and managers. Then the system will allow analysis, benchmarking, and evaluation through specific KPIs or indicators. Finally, offering the creation of a series of services for end users, municipality, citizen, enterprise, etc. So, as I announced in the 2018 Inspire conference, we discussed PELL project in the Geospatial Working Group, Geospatial Solution Working Group, where we proposed a possible linking of the PELL project with the energy pilot in the ELISE. Looking at the vision of the ELISE energy pilot, we thinking that an interoperable geospatial information, especially at the European level, is also a point of reference for the creation of value-added services. Last year, a specific multi-party agreement was signed with Jersey, as Giacomo tell in the overview of this session, in particular to improve the coordination and the effectiveness of cooperation effort in the field of use of geospatial data and technology to support the energy efficiency. So, in the context of this pilot, a preliminary investigation was carried out to verify the possibility existence of similar initiative in Europe. Maybe after we can to tell of this this survey, and now starting by the Italian data model, we propose the implementation of an European data model through a formal extension of the Inspired data specification on utility and government services, application schema, utility networks. Maybe we can tell about this also in Geospatial Solution Working Group and in the context of the agreement signed the last year. Thank you.
Thank you very much, Gabriele. Especially because with this example, I think we have very well showed the spirit of these energy and application use cases, in which we start from, in this case, from a best practice, which is already ongoing in Italy, starting from the adoption of a common data model through a consultation with all the stakeholders, and then becoming implemented with the ambition to go with all the 8,000 municipalities in Italy. There are many municipalities already using it with a lot of additional let's say hooks in terms of competences for people working in the platform, and also the concept of this smart city platform extensively used. In terms of the and then we will try now to export this best practice and reuse in Europe, thanks to the survey that we made with the members of the ISO Square working group on geospatial solutions, where after a first assessment, it seems that such a platform is not working in any other member state at this national level, also because this is becoming an instrument which is used by the government to make the public procurement of the maintenance and of this public lighting system. So a very nice platform. Just a few words in terms of the extension. Because this is one of the aims of our use case, we already started experimenting some initial tests in order to extension of the utility networks application schema according to the principles and recommendations in the generic network model of Inspire. So thank you very much again for this. And now I would like to pass to Gerard, which I see already ready. Thank you, Gerard. The floor is yours, and you will see another topic related to the energy efficiency domain, but looking at it from another perspective. Please, Gerard, go ahead.
Yeah, hello, I'm Gerard Moore. I'm from CIMNE, which is a research center in engineering located in Barcelona. We are 250 researchers dealing with different topics in our group, the big group, which is based on energy efficiency in buildings research. We are participating in 6 European projects right now at the moment, mainly Horizon 20.
Sorry, Gerard, can I please ask the other attendants to mute, please? Thank you.
Yeah, maybe there is other people having telcos at the moment.
Sorry.
It was, so maybe.
Sorry for the interaction. Don't worry. Go ahead.
Yeah. But sorry. Yeah, so well, we are participating in multiple European projects on multiple thematics, mainly European projects in demand response, big data analytics applied to energy, and data harmonization of public buildings information. So fruitful from the non-monetary agreement with the GRC, we are developing this task, the scaling up of at multiple geographical levels of characterization of electricity consumption in buildings using dynamic measured data and inspired data sets. And yeah, I will, sorry for this. Well, the goal of this use case, it's to exploit data coming from electricity metering infrastructure and Inspire data sets in order to characterize the energy losses or the usage of people in the residential sector and also in public buildings to support the government and the private sector regarding energy efficiency and energy usage trends. Okay. So as it is a scaling up methodology, we are dealing with multiple geographical levels, which are represented somehow in this schema, which is here we see the building. The building it's inside a census tract, and the census tract is conformed. Well, multiple census tracts are conformed by a postal codes, at least here in Spain. And then a city is composed by multiple postal codes, and the city is in a region. So what we are trying to do here is using this data, using the metering data, which obviously it's not, in the case, especially in the case of residential buildings, is not due to privacy aspects. We don't know exactly where the building or the household is located inside the city. We know approximately through the postal code its location, and then with this information, the metering data, the hourly metering data, and the approximate location, we can join these data sets with the weather data that we obtain online through APIs. And then we join also this data with the cadastre data from the cadastre, the national cadastre, the socioeconomic data from national statistics institutes, and vectorial. We need also the vectorial geographical levels of each of the geographical levels that I was explaining to you about. Okay. So basically, the whole methodology, it's confirmed by multiple steps. That basically the most one of the most important ones is the characterization, first of all, at individual level. So we are trying to characterize the energy characterize households and public buildings using the weather and the metering data, applying machine learning techniques, basically clustering and modeling techniques, in order to detect the user behavior and the activity patterns, where you can see here, for example, an output of a clustering technique. And then we also try to calculate or estimate the weather dependence of the models that we are training with this data, to obtain characterization indicators like heat transfer coefficient. It's obviously not the real heat transfer coefficient, because we don't have, for example, the indoor temperature, which could be a very interesting data in this case. But using the consumption and a balanced temperature, an equilibrium temperature of the building, and the outdoor temperature from the weather APIs, we could calculate a heat transfer coefficient, also the reaction of the building or the household through the air leakage, the solar gains, even depending on the azimuth and the solar zenith, standby and fixed loads, all these kind of things. And how we could scale up this individual characterization. So mainly what we do is to aggregate this data through the multiple postal codes, city, region, geographical levels, in order to compare between them. Okay, so our idea is to compare each of the postal codes in a study through their most similar ones. Okay, so to say, okay, the difference, for example, between one postal code which have a similar socioeconomic status and the buildings are more or less from the same years. You could see that the difference, there's a big difference between the HTC, for example, the heat transfer coefficient estimated of these two regions. And this could be very useful for governments in order to see problems in certain geographical zones. And also for private sector, because maybe ESCOs or these DSOs, utilities, could use this information in order to sell products or do some kind of business in this direction. Okay. The validation of these techniques that you are developing, and the development starts 2 years ago, and right now it's like a part which is finished. At this moment, we are trying to validate these techniques with 2 use cases. One use case, it's the residential household use case, and other is the public buildings use case. Both of them are located in Spain, mainly in Catalonia region. There's also some buildings for public buildings from the Castilla-La Mancha, thanks to Cardiff, which is another partner of the non-monetary agreement with the GRC. Basically, the main difference between that in the residential household use case, we have not the as the data is anonymized, we have not the location, the exact location of the building, so we could not merge the information directly from the cadastre, for example, the dwelling area, directly to the consumption data. Okay, so in this sense, the residential household characterization would regarding the geographical levels would start at the postal code level and beyond, so postal code, city, and region. And in the case of the public buildings use case, would start at the building level, because yes, we have even the cadastral reference of each of the buildings that we are calculating. Okay. The potential applications of this modeling technique, data-driven modeling technique, is to benchmark the electricity consumption of residential sector and public buildings on multiple geographical regions, cities, or districts, which could be useful for policymakers and citizens in general, because they could compare between them. It's like a gamification of the electricity consumption. To identify and assess a geographical focus group to implement energy efficiency programs, which could be useful also for policymakers, to give some subventions or economical benefits to some people of certain towns that need to develop some kind of retrofitting or something like that, and also the private sector, which could execute this retrofitting. Okay, and then two more applications could be the help of predicting maintenance of the grid, mainly to DSOs, for example, if we are trying to characterize districts or geographical areas with real data, we could execute this characterization every month, for example, and say, okay, in this district there is it seems that the heat pump installations, for example, are increasing a lot, so maybe DSO is interested with the information to perform changes in the grid, and this could be a very, very interesting data for them. And also a last application could be to infer correlations and trends among energy usage, in this case electricity usage, and socioeconomical aspects and building stock characteristics, which could be useful for policymakers and the scientific sector. Okay, some questions?
Thank you very much, Gerard. If I may, I would like to add a couple of non-pure technical considerations on top of your excellent presentation. For all the participants, Gerard, besides being a researcher at SIMNE, is also part of a startup, so part of an interesting ecosystem working in the area of Barcelona. And they are with the startup. They are putting a lot of sharing a lot of experience in using big data analytics in the clustering algorithms that Gerard showed, as well as using APIs to connect to retrieve meteorological data from government-owned services. And last but not least, the SIMNE, together with the startup, they are involved in the state-of-the-art research in this field because they are participating in many Horizon 2020 projects since many years on the topic, and that's why we succeeded in having them on board to share knowledge and experience in this field. Thank you very much, Gerard.
Welcome.
Gemma, the floor is yours, and with you now, Gemma will guide us to a regional dimension, which is another interesting aspect. You are muted, Gemma. We see your screen, but you just need to unmute yourself.
Now, right?
Okay, perfect. Go
Yeah,
ahead.
sorry for
Thank
that.
you.
Okay, so yes, as Giacomo said, now we're transitioning to the regional level. So not focusing so much on building level, but broadening the scale. We are working on this from Cartif. This is a research center and a foundation, and we are located in Spain. You can see some figures here. We're quite involved in international projects and so on. And our mission is to generate technological knowledge and innovative solutions to companies to improve their competitiveness. So in this part of the pilot, as you have seen, there are several use cases that have been explained by Volker and Christian. We're going to follow every use case, and this one is the regional use case. As you can see here, the participating organizations, and in particular in this regional strategy use case, these three entities are participating. But why these three? So we have, first of all, the Ente Regional de la Energía de Castilla y León. This is our main partner here because they are the client, so to say, or the one who are generating the challenges to be solved with Inspire processes. This is the regional agency of Castilla y León, and they are currently developing regional energy strategies in this region. And they're working on the new regional energy strategy for 2021 to 2030. And they would like to test currently how data could be included within their data flows to enhance the establishment of the objectives and how they can monitor the progress of the newly developed regional energy strategy. Also participating with a more technical focus is Cartif, as I explained. And we are in Spain as well. And we try to bring research and innovation to stakeholders. We have experience in energy assessment at different scales. We are knowledgeable of geospatial data treatment experience, and we generate support tools for planning purposes. And of course, the GRC managing the energy and location pilot is crucial, and as well because of the Inspire directive policy support and validation. So with this, we're trying to pursue the following objectives. So it is composed of three parts, the objectives that are to be followed. First of all, we would like to understand the European context in the regional planning, from the regional planning perspective. So the first part is to analyze the EU member states' energy competences. We would like to have a map of how the different countries are structured in order, from an administrative perspective, in order to know how replicable the methodology that we proposed can be applied in other regions. And also, we would like to know, and we are currently analyzing, how publicly available EU datasets can be used and integrated. Not only those coming from Inspire, but also complementary sources, as we will see now. This will be reflected in this deliverable once finished. One part is trying to take a real case. In this sense, we took the regional energy efficiency strategy of Castilla y León. And firstly, we have analyzed the context and the main aim of the strategy, the structure and the sectors that are covered. And we have reviewed the methodology and detected potential improvements that could be improved with this methodology. Whoops. Then finally, we have to analyze the inspired potential to support this regional energy planning, not only based on the specific area that we have selected to deploy the case study, but also from an European perspective. So we have to analyze the relevant inspired data sets that could be used in this type of problem to generate regional energy strategies, and also test what is available in this Inspire GeoPortal, and more specifically, what is available in the Castilla y León region, because then we would like to test it, and actually test it because they are developing the strategy currently. So it is time-wise a very nice use case. So the first bullet is understanding the EU context. As I said before, we are analyzing what type of data is available and how it can be integrated within our regional energy strategy. As you can see here from the logos, we are analyzing different data sources. Eurostat is very common, the European data portal, also what is coming from the European Committee of the Regions, from the European Environment Agency, the building stock, and also characterizing the building stock from other projects, OpenStreetMaps, or other data sources where we can learn about the other strategies that are implemented at territorial level. So yeah, these are some of the data sources that we are analyzing. Particularly interesting, we're trying to see also the different statistics that are in Eurostat related to the NUTS levels, and trying to see how they can be integrated and enable the replicability of this methodologies. Then we are testing this applicability of the regional energy strategy in this specific region, the Castilla y León region in Spain. As you can see, this is the biggest region that we have in Spain. However, it is have a high density. As I mentioned here, this characterization of the region is really key for the regional energy strategy. Here, only three parameters are mentioned, but a lot of other have to be analyzed, because the regional energy strategy focuses on many different sectors that are influenced by many different aspects that should be considered. And if we intend to devise a methodology that could be replicated in other regions in Europe, we should know how to very well characterize the regions so that it can be replicable. So the sectors that are tackled in the regional energy strategy are 6 for the moment: industry, built environment, transport, public services, administration, and research and financing. And these are tackled at different stages. So firstly, there is a baseline establishment, so trying to analyze how the region is currently performing. Then based on this diagnosis, some objectives are set. These are set based on the directives that should be complied with by the region. In particular, the energy efficiency strategy is of reference here. And then there is also the monitoring of the strategy which should be in place. For the moment, the main difficulties that we have detected so far and experienced by the EDEN, by the Regional Energy Agency, are the data availability and how often are these data updated. Also, the different scales of the data that they have to use and how they match with each other. So we're currently tackling that and trying to see how these processes can be supported. Finally, we are to detect how the Inspire potential, how big is the Inspire potential to support this regional energy planning in the EU. As you can see in the picture, we are not focusing just on, or we intend not to focus just on specific themes, but we want to analyze how all the different themes can be of use, because when having analyzed the regional energy strategy in Castilla y León, we have realized that a lot of varied data are used to contextualize everything. So we believe that a lot of Inspire data can be of support, but also this has to be contrasted with what type of data is currently available that could support this. So we want to define it at a theoretical level, but also test it practically. So to conclude, the contextualization and analysis of these data flows and the frequency update, as I mentioned before, of data is crucial in this development of regional energy strategies. Also, what we have detected so far is that there is a great variety of data sets and corresponding to different sectors, scales, and it is difficult to be harmonized, but we are currently working on that. So the integration of these geolocated data and the results will be obtained at the end of the year. So that will be all from my side.
Thank you very much, Gemma. Also, as a non-technical consideration here, I would emphasize that in this use case, you as Cardiff, as a research center, are working very closely to REN, which is a public body, is a regional energy strategy, concretely engaged in the renewal of the regional energy strategy. So thanks for the hopefully continuous win-win engagement that you are achieving. So thanks again. Now it's my turn, and share screen. Okay. So I will present the next two use cases of the energy and location applications under the ELISE action, even though is as you can see from the contributors, is a joint effort for all the partners participating in these use cases. So the first one is the EPC for EU, which is an acronym that we still didn't patent yet, but we believe can be a good anchor point for the EPC. Stands for Energy Performance Certificates across Europe. So the EPC for EU data model as a building block for the harmonization and the interoperability of EPC's databases across Europe. The starting point for the EPC for EU was the Inspire harmonization of EPC datasets in Italy that we presented in the last Inspire conference, and basically starting from the Inspire building to the core data model, we analyzed the EPC data model. You see here EPC for EU version 2, because in the first version there was a regional data model as it occurs in other member states. But then we shifted to a second version in which model was entered into force. So the first attempt to create this EPC4EU data model was to comply, to make it usable for data harmonization exercise for the EPC of the Italian database. And we worked together with the autonomous province of Trento, the provincial energy agency. They are managing the EPC database. So starting from that, we went to the first attempt to extend it to another country, in this case, Spain. The methodology was the classical one, to analyze the source data model, in this case, the Spanish EPC data model, and analyzing what we achieved so far in terms of target data model, which, by the way, was a formal extension of Inspire Core Building 2D. And then with the classical mapping exercise, we identified the missing attributes, and then we generated a version 3.0 of the EPC4EU data model, consisting of the classical pieces, the UML conceptual model, the mapping table, and the XSD, the GML application schema. And then we used these to make an harmonization of a sample data provided again by RN in the Valladolid region. This is a snapshot of the UML data model. You can see on the left the building base and the building 2D core of Inspire, and then on the right side, new feature types that we defined in order to accomplish all the semantics contained in the EPCs, starting from data contained in a pure certificate, but then also in the energy system and energy conversion system. In this case, I have to point out that in order to maximize the reuse of existing stuff, we benefited a lot from the work done by the OGC, the group working on the energy, CTGML energy application domain group, and we took a lot of their classes to make this extension. This is the classical matching table that any Inspire data transformer is using, and then a screenshot of the valid XSD schema. So the intermediate point of our journey was the Inspire harmonization of EPC dataset in Spain. We started from here. Then we took into consideration the data model of EPC of Spain, which was a bit different from the one in Italy. And therefore, we achieved the version 3, including some additional attributes not foreseen in the data model for Italy, making this version 3. And then you see the first for us excellent achievement, in which in this screenshot you can see in the two circles, red circles, a first exercise of the harmonization using the same data model of energy performance certificates in the Trento region in Italy, as well as in the Valladolid region in Spain. Then zooming a bit in, this is, you can see with a simple QGIS screenshot, the highlighted in yellow building in this map on the complex GML info attribute here, the attributes belonging to the data model. This is the another zoomed in screenshot showing the classified view in the case of Trento, in which we are using here simply the labeling classification to show the labels in terms of energy performance certificates, showing how flexible can be this data model in order to serve different needs. This is the next step, the next point. So the extension to other member states, and the idea is that worked very well for the first case for Spain, starting from Italy. We can add as many other member states, trying to continue with the exercise to extend on top of the Inspire building 2D core, the EPC4AU, which can solve the well-known issues, as very recently highlighted also in the Building Stock Observatory webinar hosted by DG Ener a few weeks ago, is another barrier for the full interoperability of such an important piece of information, because this data model can use not only to show roofs of the buildings colored in terms of labels, but you can, according to the semantic richness of the model, we can thematize and show many other aspects related to the energy systems and the energy conversion systems. So I will switch to the next one before to leave the floor to Neil for the last presentation. This is another use case named interoperability of SECAP data. SECAP stands for Sustainable Energy and Climate Action Plan, part of the Covenant of Mayor initiative. So we touched another aspect of the energy efficiency domain. So what this use case stands for aims to show the benefits of harmonizing and improving the usability of the data contained in the Sustainable Energy Action Plans produced by the local authorities, which are signatories of the Covenant, which I have to highlight here is a voluntary initiative to self-commit to for local communities to achieve, to contribute to achieve the targets set by the energy policy framework. And the idea here is to better support the coordination of energy policies at local level, because the Covenant of Mayors involves municipalities which are spread around the world, even though in Europe there are most of them, but sometimes there are needed to have a coordination at upper territorial level. Indeed, the methodologies developed in this use case are being tested with more than 70 SECAPs produced by local authorities of the autonomous province of Trento, and which support the regional agency of Trento in its role of coordinator of energy policies at provincial level. The methodology again is to analyze the source data model consisting of tables extracted from a Covenant of Mayor database and from a complete database structure, restricting the interest, the focus now to the municipalities coordinated by the province of Trento. Then we analyzed the Inspire reference target data model, consisting of area management theme and schema, and then we extended it containing, adding additional feature types and attributes needed to map all the information present in the SECAPs. We started from area management because the signature of the Covenant of Mayors represent the legal base, even though it is a voluntary initiative, is the legal base adopted by the municipality councils, and so fitting for to the area management concept. So we extended it and we transformed sample data according to this extended target data model, and we are now currently involved in the publication of the harmonized data through WFS Direct Access download service, and also as well as WMS. These are the source data in a plain file starting from a CSV extraction from this database. And this is the very complex database structure which is used on a daily basis to monitor at a European level all the data provided by the Covenant of Mayor signatory. This is the extension of area management data model, in which you see on the right-hand side in green background the SECAP feature type, which through the associations and some constraints. So the mandatory association has emission inventory, and then the optional one has a mitigation action, has adaptation actions, and has risks and vulnerabilities. allows to map all the data contained in the SECAPs that we analyzed. This we made the example of data transformation using OpenSUSE PELL Studio software, and here you see the final output, in which again in a QGIS environment, but we can reuse it also easily in web applications. We see the as a base map, the OpenStreetMap. On top of it, the vector layer represented by WFS, sorry, retrieving the municipality boundaries of the province of Trento, and then the features represented with the dots of the first harmonization effort of these SECAP data, and on the right all the attributes. Particularly interesting was the also data related to costs of the action, which in this case the regional energy agency of province of Trento asked to have for a better coordination. I have to say that here the interest, because the work is done in close cooperation with the unit of the GRC, providing technical assistance to the COM office, Covenant of Mayor office. They are very interested in this harmonization effort, because especially now that the COM is going globally, it can be its reuse can be beneficial in many other contexts. Okay, having said that, I would like to stop sharing, and I would pass the floor to Neil for the last speed presentation of today. So Neil,
Hi, Giacomo. Thank you.
The floor is yours.
That's great. Thank you. Okay, so I will share my screen.
Okay, perfect.
Okay.
We have it.
Okay, that's great. Thanks. So, thanks everybody for joining. There's been some really interesting presentations, and I think there's some really interesting work being done in the area of geographic information for energy systems, and I hope to connect with some or all of you after this. So just to get into it, my name's Niall Conway. I'm the project manager of a project called REDAP, which stands for Regional Energy Demand Analysis Portal. And the project is funded under a different program. It's a separate Horizon 2020 program, and it's called ERANET Smart Energy Systems. So the focus of ERANET is it's on integrated regional energy systems. They have two programs. One is on regional energy systems, and the other one is on Smart Grids Plus. So basically, I'd see the direction of ERANET moving in the future is well, from the interest is from the organizers is definitely on the topic of digitalization, and where better to look for digitalization than GIS locational data. So I suppose that's really the focus of our project at the moment. It's on looking at regions as geographic information regions and trying to extract some information on the energy demand. So I suppose REDAP is, in a way, I like to think that it's a project that's about advancing the green digital agenda of the European Union at the moment. If there's going to be an economic recovery, that there could be a lot of innovation comes out of this area, and I definitely think digitalization is where that's going to happen. So just the next slide. So REDAP essentially it's a GovTech system. It's focused on local governments, energy agencies of the regions, and we're working with 3 focus regions in this project. So that is Gothenburg in Sweden, the Dublin region, and also Weidhofen and der Thaya. It's an Austrian rural region. So I suppose when we look at regions, we don't look at them as, we look at the common characteristics. We don't look at them as different kind of distinct regions. What we're trying to do within this project is overcome some of the differences so that we can build a standardized process which can be replicated across regions for analyzing energy demand. So our real focus is on the socio-economic characteristics and patterns of this energy demand. And what we hope to achieve through this is to drive energy efficiency and improve the performance of these regions. Currently, the REDAP is based on a process which has been developed by the Dublin Energy Agency, which is one of the partners. It's called CODEMA, and basically they use a process called Spatial Energy Demand Analysis, and it's a GIS-based process. It's about it's used to inform the Dublin Energy Master Plan. It's also used to help them report to the Covenant of Mayors reporting requirements. It's also used for developing the Sustainable Energy Action Plan. So basically, it's based on a process that exists and a process that works. And what we're trying to do is standardize this process to make it even more replicable across distinct regions. So the next one is we work with, I mentioned CODEMA, which is the Dublin Energy Agency. They work with the 4 Dublin local authorities to develop a better informed energy planning decisions. They represent the 4 local authorities, which combined about 1.5 million people. We also work with the City of Gothenburg Council in Sweden, which is about 500,000 people, and also the Energy Agency of the regions, which works with local energy users, stakeholders, local governments in the Northern Austrian region. So I suppose the reason why we're doing this is because each of these need owners, they're the frontline energy planning experts. They help to implement the policy of the 3 funding agencies of this project, which is the Sustainable Energy Authority of Ireland, the Austrian Innovation Fund, and also the Swedish Energy Agency. So basically, they are the people implementing decarbonization strategies, electrification, reducing emissions among different industries, the transport sector, building sector. So just using a few examples, basically we have Ireland is a net importer of energy. There's an estimated 5.7 billion per annum worth of energy, and it's similar in Austria and other countries that basically they want to kind of, look at local reliable sources of supply. But in order to supply that energy, you've got to understand the breakdown of the demand across these cities. You've got to understand, what are the demographics, what are the what fuel type is currently being used. The buildings, are they residential, are they commercial, are they public sector buildings? So that's basically what REDAP is about. It's about breaking down the characteristics, socioeconomic characteristics of this demand. Okay, so the REDAP also has some potential high-level services. I mentioned that the funding agencies behind the project are, basically government agencies. So we like to think that the insights that we're deriving at a local level through the energy agencies, which are focused on their own distinct regions, could be used to inform more macro level insights, which would inform a further, investment planning, upgrades. At the broader level, the European Strategic Energy Technology Plan, the Integrated Single Energy Market, which is slowly emerging. So I think there's potential scope for designing digitalization systems which will make those more macro level policy and plans implementable. So also the topics of energy security at the local, regional, and national level. Regional development is a huge topic as well. As different kind of ICT communication technology broadband plans allow for more movement remotely across different regions, and also the topic of projects of common interest. The various interconnectors that are being built across Europe. There will be sharing of electricity across these regions. So I think it's understanding the energy demand is going to be it's going to be quite important. So at the end of the day, READUP is about delivering an extra layer of decision-making certainty to energy stakeholders. So in terms of the READUP project started last November. We're about 7 months in at this stage. By the end of this year, we hope to have a demonstration system in place. But here's just a graphic of how we envisage it will look. It will be a web map. It will show infrastructure, planning, administrative boundaries, statistical demographic information. It will focus largely on the use of transport surveys, travel information from authoritative sources, the transport agencies, the EPBC, the buildings data sets. It'll be about visualizing geographic information. It'll be about statistical analysis and allowing the overlay of additional, mainly planning and policy data sets. So I suppose where we see READUP right now is, in 2021, it will be like the system. It'll be like what you have to do is, get information, HTTP get. You'll be able to call down data so that you can see it. But beyond this phase, we hope that it'll be more about post, put, delete, interacting with the data. So it'll be more of a kind of a digital twin system for energy demand analysis. So I suppose what I mean by the chart down the bottom is that where we are at the moment with READUP and how it will be used by the energy agencies is similar to how any major energy project, physical infrastructure will be developed. They have the concept and the planning stages, and that's where they kind of, decide if they'll go ahead with projects. But later on in the project, we hope that as the system it becomes more standardized, more relied upon, that it will be more a system that can be used for the development phases, the operation phases, and the decommissioning phases of smart energy infrastructure across Europe, or across these distinct regions anyway. So READUP is about delivering, and ERANET, one of their key focus is on cross-sectoral, focus, that it's not just about one different sector of buildings, that, they hope that it will integrate with other sectors of energy that it will be about. So in our case, we're looking at energy demand in terms of mobility, and buildings. And the types of insights derived will be energy demand per region, per transport mode, or the average energy demand across for transport across different regions. So if there's residential areas, well, what is the average energy demand? How can this energy demand be potentially supplied by electrified sources, decarbonized sources? Also buildings, identify where's areas of fuel poverty, what's the average fuel usage, the average expenditure, and that's per different breakdown of building types, residential, commercial. So I suppose when thinking about REDAP, we like to think of it in terms of landscape, and we like to look at these regions in terms of an energy demand landscape. And what I mean by that is that within these landscape, we have different spaces, represented by buildings, and also the linear connections between these spaces. And that's where really geographic information ties in, because you have polygon, you have point, you have linear data sets, and what we're trying to do is just build a kind of representation of the energy demand landscape in that way. So I suppose our process in developing a standardized process that can work across regions, it's about cleansing, visualizing, integrating, and analyzing different types of data sets. And obviously we need to kind of standardize the distinct data. Even though a lot of the data sets that we're working with, some of them are INSPIRE compliant. Definitely the systems we're working with are interoperable, but there's a lot of standardization that needs to take place, based on the source of the data sets. If it's from Ordnance Survey, or if it's from statistical or transport surveys. So the end goal of REDAP, I suppose, is we want to help the need owners, the frontline energy planning experts, to make better informed decisions, more sustainable, decarbonization decisions. And a big part of their focus at the moment, it's not so much the key need for them at the moment is to fulfill the monitoring and reporting requirements. And that will be in relation to, say, Covenant of Mayors, energy action plans, baseline, energy assessments. But also, I suppose, we want to give them confidence where, by understanding the energy demand, we will help them to justify their actions if required, or the difficult decisions that need to be made in transitioning from a fuel-based network to a more decarbonized sources. So I suppose their key focus at the moment in terms of the decarbonization is they need to understand how they can utilize waste energy through district heating networks. Data centers are going to be a huge source of energy demand. So, what are the efficiencies that can be gained through better kind of planning, better decision making, EV charging, obviously, and the crossover between and EV charging is a huge one at the moment that needs to be understood. Public lighting, retrofit strategy for, and also public buildings will be a key focus of decarbonisation across at least the Dublin region. That they will be demonstrator projects of what can work across.
Neil, 2 minutes, please.
Oh yeah, sure. I'm nearly there. Okay, so just in terms of our process, we're about collating distinct information from different sources. We're about integrating, aligning this kind of information and system with existing decision-making processes. So it's about understanding the relationship between the decision-making processes, the relationships, the key stakeholders. It will also be about developing a database-driven decision-making system, which can be used to support, not replace, the need owners' processes. We want to kind of supercharge their capabilities. And so also it'll be about testing and maintenance, and then delivering actionable insights to key decision makers. Then in terms of the just the technology we're using OGC compliant software. We hope to use Inspire compliant as much as possible. I think that will be a key next phase of our project. And so finally, look, as I mentioned at the start, I think there's a lot of interesting work being done, by the geographic community in Europe, and especially at some of the discussion presentations. So, if you think there's any kind of connection, potential collaborations that we can discuss later on, please do get in touch. You can check out the website and you can contact myself through the website also. So thank you very much. I think the green digital transition is going to be a big opportunity for geographic professionals. So okay, thank you.
Thank you, Neil, for your excellent presentation, which by chance was the last one, but I think gave a very nice comprehensive view of all aspects that have been dealt with at the beginning. I'm fully aware that I'm keeping you away a few minutes more for your very deserved lunch, but I think it's time now. Now it's time to go for the Slido. Polls, I will share my screen, and I will simply go here, and then I will activate the first poll in which you are asked to vote. So to what extent, in your opinion, are the problems addressed in the presentations representative of the challenges of the EU energy policy framework? As I said, we tried to be as much as representative as possible, but we would like to know your opinion about that. Counting to improve from your valuable feedback. I see only 7 people voting. I remind that you just need to go to open a new, or with your smartphone, or open a new window in your browser, Slido, and put the code Inspire 2020 when asked. I counted almost still 60 participants, even though some of them had to leave. So please vote, because we count a lot on your feedback. Just a few seconds more. Okay, I think the trend is encouraging, even though we will always try to improve the representativeness of our use cases. So I propose to go to the next one. To what extent do the solutions presented have the potential to support the life cycle of the EU energy policy framework? So apart the representativeness, now please consider and vote they can support. They try to achieve 20 respondents, like in the previous poll. At least 1/3 will participate. By the way, I think that the trend here is again encouraging for us. So I propose to move to the next one. how replicable, reusable are the solutions presented in other geographical contexts, and please rate from 1 not at all to 5 highly replicable and reusable. Of course, our aim, as I mentioned before, is to start from use cases with some specific data set in a specific area, but the aim is to generalize as much as possible the methodology in order to maximize the reusability. But despite this is a name pervading our work, we're not fully confident to achieve these ambitions. So please give us your feedback. I think it's good to know that you are assessing a high level of replicability and reusability, which is again encouraging. All right, let's go to we have another one. That's is a bit more challenging. So to what extent the solutions presented are concrete examples to feed data ecosystems, data spaces, digital twins that we heard intensively in the previous presentations in the past days in a more conceptual way with some examples, of course, but it's interesting to position our work in the context of the emerging data policies. It seems that we reached the threshold of the people still willing to contribute so much. And then let's go to the last one. Which additional topic related to energy and location would you have liked to hear about in this webinar? So please feel free. I saw that, I guess I can imagine one reply looking also at the chat in which there was suggestion to look at another component. This is the last effort required to you. Interesting suggestions. Somehow we touched upon some of these aspects, but not fully exploited, at least in the presentation, like the IoT world, for instance. In the Gerard presentations, the smart meters are playing a key role in that use case. PV potential, that's true. In terms of examples of renewables, when we had to scope the use cases so far, we had, let's say, some limited resource to count on, but it's a good point, of course. Okay. thanks for having replied also to this question. Let me go back to the chat. There is a question from Gerard. What's the main challenges to ensure predictable, updated, authoritative data supplies? Challenging question. Who would like to reply to that? Maybe Volker?
Yeah, that's a very tricky
Yeah.
question, a very difficult topic. Yeah, that we from Germany, put it this way. Yeah, a lot of data is available on the municipality level, but is monitored on say district level, or should be monitored because they are in a way responsible for climate for this climate plans and improvement, but they do not get the data from the municipalities. And that is one of the it's really a challenge to say make this data sharing and data supply in a way
Let me complement that probably is a common hope that these big pushing toward the setting up of these data ecosystems in which the participation of different types of stakeholders in a specific domain, but interoperable cross-sector and cross-border, can contribute to that. Because for the time being, we saw a lot of examples and stated in the policy statements, but I guess and I hope that in the near future, building also on top of the some very good examples showed, for instance, in the presentation of the Green Deal, the Smart City presentation, there is a ground to grow. Okay.
I think one challenge is the question. I think a lot of data is available on municipality level, but they usually lack of resources to share this data. So some responsible person on municipality level and some funding, that would help a lot, I think.
Okay. Thank you, Volker. And let me conclude with a remarking slide. Just a moment. So for those of you interested to follow up what we are doing here in these energy location applications, first of all, I will copy here the copy and put in the chat the link to keep updated, where you will see also the recording as well as in the Inspire website, and to follow up the ongoing progress of the activities which are planned to end by the end of this year on the spring next year. I thank all of you for your patience and your passion to follow this webinar. I hope we satisfied your expectations in terms of looking at how energy geospatial data interoperability can support energy efficiency policy life cycle, which is very broad. And have a great time and enjoy the rest of the day, of the week. Have a good weekend, and let's hope to keep in touch. Thank you again, and bye-bye.
Bye-bye, everybody.
Thanks.
Goodbye, everyone.
See you.
Thank you.